Okay, now we're going to look at solving quadratic equations by the square root property. So the key thing here is that if we have u squared equals d, then we're going to square root both sides, but we need to make sure we put plus or minus in front. So if u squared equals d, then u equals plus or minus the square root of d. Also, we want to make sure we always isolate the squared expression on one side of the equation. So that could be x squared, or that could be the quantity of x plus 4 squared, either way. Okay, so looking at A, 3x squared minus 15 equals 0. So we're going to start off with adding 15 on both sides so we can isolate the x squared. So 3x squared equals 15. Divide both sides by 3. X squared equals 5. Square root both sides to get rid of the squared, and we're left with x equals plus or minus. We can't take the square root of 5, so we're just left with that. And leave your answer exact unless it asks for a decimal in your homework. All right, looking at B, we have 9x squared plus 25 equals 0. So we're going to start off with subtracting 25 on both sides. So 9x squared equals negative 25. We're going to divide by 9. So x squared equals negative 25 over 9. We can't reduce that, and 9 doesn't go into 25, so we're just going to leave it a fraction. And then we're going to square root both sides. So we have x equals plus or minus. So the square root of a negative, remember we have I, so I'm going to kind of leave a space and put that on the end. And then we can break this apart to be the square root of 25, or negative 25, over the square root of 9. The square root of 25 is 5, and the square root of 9 is 3. So x equals plus or minus 5/3 I. Okay, and then the quantity of x minus 2 squared equals 6. So here is an example of when we already have a squared expression isolated. So x minus 2 squared, we're going to go ahead and take the square root of both sides. So we have x minus 2 equals plus or minus the square root of 6. We can't simplify that any further, so it's just going to stay the way it is. And then to get x by itself, we're going to add 2. So x equals 2 plus or minus the square root of 6. Okay, so now looking at the quadratic formula. So the solutions of a quadratic equation in general form are given by the quadratic formula. X equals negative b plus or minus b squared minus 4ac all over 2a. If you don't know that, make sure you memorize that or have it written down somewhere. Okay, so again, we always want to make sure we're equal to 0. So in this first example, 8x squared plus 2x minus 1 equals 0. We're good to go there. And then I'm going to go ahead and say what a equals. Here we have 8, b equals 2, and c equals negative 1. And the key thing here is you're not going to put your variables in. You're just using the coefficients and the constant. So if we plug in, we have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 8 times negative 1 all over 2 times 8. So if we simplify, we have negative 2 plus or minus the square root. 2 squared is 4. Negative 4 times 8 is negative 32, times negative 1 is a positive 32. All over 2 times 8 is 16. We have negative 2 plus or minus the square root of 4 plus 32 is 36, all over 16, which equals negative 2 plus or minus the square root of 36 is 6 over 16. And then we're going to break this up into two equations. So we have x equals -2 plus 6 over 16. And we have x equals -2 minus 6 over 16. And then simplify. So -2 plus 6 is 4. And 4 divided by 16 can reduce to be 1/4. -2 minus 6 is -8. Divided by 16 can reduce to be -1/2. So x equals 1/4 and -1/2. Okay, looking at B, 2x squared minus 6x plus 1 equals 0. So A equals 2, B equals -6, and C equals 1. So plugging into our quadratic formula, we have x equals -6 plus or minus the square root of -6 squared minus 4 times 2 times 1 all over 2 times 2. -6 is a +6 plus or minus the square root. So -6 squared is a +36 minus 4 times 2 is 8 times 1 is still 8 over 2 times 2 is 4. So we have 6 plus or minus the square root. 36 minus 8 is 28 all over 4. Okay, the square root of 28 doesn't simplify perfectly, but we can break it apart. So the square root of 28 can be broken up to the square root of 4 times the square root of 7, and the square root of 4 is 2. So this can be rewritten, x equals 6 plus or minus 2 square root of 7 over 4. And then you have to be careful. We want to check. So our outside numbers, can they all be divided by the same thing? And they can. They can all be reduced by 2. So we're going to divide everything by 2. So we get 3 plus or minus the square root of 7 over 2. And I'm okay with you writing it with a plus or minus sign. If you would rather write it out into 2 separate, that's fine. But do not feel like you have to. All right, and looking at C, we have 3x squared minus 2x plus 4. So A equals 3, B equals -2, and C equals 4. So we have x equals -2 plus or minus the square root of -2 squared minus 4 times 3 times 4 all over 2 times 3. So -2 is a +2 plus or minus the square root. -2 squared is 4 minus 4 times 3 is 12, and 12 times 4 is 48. All over 2 times 3 is 6. So we have 2 plus or minus the square root. 4 minus 48 is a -44 over 6. So the square root of -44, that can be broken up to the square root of -1, the square root of 4, and the square root of 11, which gives us 2 square root of 11, I. And careful to make sure your I is outside of the square root. So x equals 2 plus or minus 2 square root of 11, I, all over 6. And then check your outside numbers. 2, 2, and 6. Those are all divisible by 2. So we have 1 plus or minus the square root of 11i all over 6. Okay. It is a complex number, so if you wanted, you could rewrite this as x equals 1/6 plus or minus the square root of 11 over 6 times I. Okay, and lastly, we're going to talk about the discriminant. So remember, your solutions are always just your x-intercepts. So here we have examples of the graph. But whenever your discriminant, so the inside of the square root portion of the quadratic formula, is positive, we have two solutions. I'm going to say two real solutions. Okay, when it's equal to 0, we're going to have one real solution. And when it's negative, we're going to have two complex solutions. So just like what we saw in that last problem. Okay, so for each equation, compute the discriminant, then determine the number and type of solutions. So remember our discriminant is b squared minus 4ac. So we're going to start off, make sure you're equal to 0, and then state what a equals, b, and c. And then plug in. So we have 4 squared minus 4 times 3 times negative 5. 4 squared is 16. Negative 4 times 3 is a negative 12. And negative 12 times negative 5 is a positive 60. 16 plus 60 is 76. So our discriminant equals 76, which is a positive, which means we're going to have two real solutions. Okay, and then looking at b, we have 9x squared minus 6x plus 1. So a equals 9, b equals negative 6, and c equals 1. So if we plug in, we have the quantity of negative 6 squared minus 4 times 9 times 1. Negative 6 squared is a positive 36. Minus 4 times 9 is 36 times 1 is 36, which equals 0. So our discriminant is 0, which gives us one real solution.